And so I decided to take a few minutes and talk through broad categories that you see displayed here on the board, and we will cover them one by one. So starting with the general term model, what do we mean? Typically, a model is a simplification of what? Of a complex phenomenon. How do we make it a little more real? So let's think of some examples. For instance, a car, it's a complex object. A model car that we get as a kit or as a toy is a simplification. It doesn't have all the features. It could be still big enough that maybe a child can get into it, or at least it's remote controlled. Similarly, even a more complex phenomenon is an airplane, and you can think of these as another way of capturing that complexity and simplifying it. These are examples of what we would call physical models. When we talk about AI, machine learning as a category, discipline, we are typically talking computers. Those are the machines that we mention. And so we are more looking at abstract or mathematical models. So we keep that in mind here, that we are talking about abstract or mathematical models that simplify a complex phenomena. These models are used in different ways that classify as AI or machine learning use cases. What we then start to think about, in fact, over the last 5 or 8 years, is this field of computer vision. So a very popular application area for AI has been computer vision, where we are doing things like image classification or object detection and things of that nature. And the type of models that are used are called neural networks. And you might have heard these words in different contexts: deep neural network, artificial neural network, convolutional neural network, recurrent neural network. These are all different terms that get used. So think of these as a type of model that is used in computer vision. And basically what we are trying to do, for example, is, let's say, tell apart a cat versus a dog. You give it an image, and the neural network model is able to help determine if it's a cat or a dog. It mimics, the word neural came from the fact that it mimics human or animal brain. How does it do that? Well, there is neurons sending electrical signals. So, when a detection of some sort happens, a recognition, the brain neurons in the brain are fired, and an electrical signal is sent to the next neuron and the next. So that's kind of how this abstract mathematical model is designed to work. It has what are called parameters. So this is the size of the model, how many million parameters, and these days we get into even larger numbers that capture that abstraction. And the values that these parameters take on are called weights. So you hear about, oh, I'm adjusting. You talk to a data scientist, the data scientist will say, I'm adjusting the weights of my parameter, don't bother me. That's kind of what they are doing. They are actually learning the weights. How? By going through a process that we have all come to say or know as training. So the model is supplied with a lot of images, cats and dogs of different shapes and sizes and different surroundings and environments. And during training phase, the model weights are adjusted or learned. And at some point, of course, the training stops, and then you transition into using the model, and the technical term we often hear is inference with that model. So that's really where we get in to training in getting the weights. And the usage is basically what's happening here is we have an image of a cat or a dog in, and out comes yes or no, like a binary output. Is it a cat? Yes or no. You can do it for other classes, right? That's kind of the thought process there. Let's transition to a more recent topic that we talk about called language models. So the connection is that language, for example, English is complex. So that's the complex phenomenon we talked about. And the model is trying to capture a simplified abstraction. So here what's happening is words or text in, and out comes other words or text out. So for example, you are interacting with things like, these days it's very popular to say chatbots. Another example is Q&A systems. So a question or a prompt, as they call them, is given, that's the words in, and the answer or the response you get are the words out. These models can get very large. So that's why you hear the word LLM, and I'm going to put it in parentheses here, large language models. The LLM stands for large language model, because English or any other language that you pick requires a model to be very large. What does it mean that they are large? All that means is the weights or the parameters that capture the abstraction of that complex object, in this case a language, are so many. We talk in terms of billions and nowadays even trillions of parameters. They require a lot of memory to store. So that's where the reference is to the large language model, the word large in there. Because they are so large, we get into an aspect. Let me change colors here just to make that point stand out. Because they are so large, we talk about pre-training them. Pre-trained. Basically what this means is that the model is fed all available, let's say, English text. So you crawl the web and get your hands on every English sentence or text or reports or books or what have you, and you feed it as training input data to the model. And so the model gets pre-trained, and then once you are done training it, it's available for use. The special thing about these large language models, pre-trained models, is that once you have pre-trained them, you don't need to keep on doing that process, and they are available for use in variety of these systems. Let's see, what other phrase I want to talk about. The fact that words are coming out, meaning it is generating a sentence. It's generating the next word. Let's say not even the full sentence right away, it's doing word at a time. So it is generating the next word. And how does it know to put out the next word? From the training or pre-training phase, it has collected the set of probabilities of a word coming after a set of prior words. So for example, in the language English, the words "the quick brown" is most likely or most often followed by the word "fox." So of all the 10,000 words or 15,000 words in English language, fox will have the highest probability of being the next. And the model didn't know this until it was pre-trained on that available text. So it kind of gives you a flow idea of how the model picked out those probabilities, and then when we ask a question or we give it a prompt, is going back and picking out the most likely words. The last thing to add here is the architecture of the model, and there is a new architecture that has been talked about called transformer. And transformer takes an input in this case and converts it into an output, and the details are very interesting. We won't get into them right now, but I was going through this sequence for a specific reason, and you may recognize that the three letters at the start of this are GPT. And today we are all talking about, in the world of AI, this notion of ChatGPT or GPT-4. The next one coming out is GPT-5 soon here. And the idea is that this whole field that is emerging is being named as generative or Gen AI for short, and it's really Gen AI. So you've gone from computer vision to generative AI, where we are not just calling out, classifying whether it's a cat or not. We are here now taking in as text and going to the words. The last topic that I want to get to is foundation models. You may have also heard this in the context of generative AI discussion. And basically what's happening with foundation models is that it's able to handle as input text, images. So you may hear the word multimodal. So these are modes, modal. So one mode is text, another mode is image, and there could be audio and other things. And what's happening is that when you are able to work with data of more than one type, here it was just text, here it was images, now we are talking about in foundation model either or. And you could talk about text in, image out. So this is where you have the ability to provide a prompt saying, draw me unicorn traveling in space, wearing a helmet, eating an ice cream or something like that, and out comes an image that basically captured those words. Text in, image out. There is also the reverse, that I supply an image and say, describe to me what's shown in this image. And it might be a photo of somebody relaxing by the beach, and it will describe, I see the ocean, and I see a chair and an umbrella and some sand and so on. So these are the capabilities where we have come. So multimodal, and the general term there, instead of just talking about language models or even large language models, we say the term foundation models. I have so far talked about what these are, and I would invite you to tune in to the next video in this series, where we will get into how these are used in different settings. We kind of hinted at them, but we will get into a little more detail about them. With that, let me stop. Hopefully this was interesting, and you are walking away with a little bit more knowledge about these very popular topics. Thank you.